Alright, so section 5.1 is on something called polynomials and different operations with polynomials. So the goals for this section, we want to first of all talk about what we mean by the law of exponents. Those are just properties that apply to things when you're raising different powers or different exponents. And then we'll talk about the four basic math operations: adding, subtracting, multiplying, dividing. We'll talk about three of them when it comes to polynomials. In section 5.2 we'll talk about the last one, which is dividing. So first of all, here are the properties for powers of x. The ones that a lot of people tend to mix up would be this one and this one. People get those confused. So a simple way to remember this: suppose I had x squared times x to the third versus x squared the whole thing to the third. So here, if you can remember this simple example, you'll be able to tell these apart. X squared, that's the same thing as x times x. X cubed is the same as x times x times x. If you now combine this whole thing into one compact result, you have x to the fifth. Ask yourself, how did you get 5 using the numbers 2 and 3? And the answer is you added them together. That's what this property means. Down here, on the other hand, x squared, the whole thing to the third, that's the same as x squared times x squared times x squared. And now we're back at the problem like what we just did. We're supposed to take these 2 and 2 and 2 and add them together. 2 plus 2 plus 2 equals 6. How did you get 6 using these numbers? You multiplied them. So the first one says when you're doing x to the something times x to the something, you add them. Down here, when you're taking x squared and you're raising that to a power, you multiply them. These middle two properties are just extensions. So this one right here, let's say we had x to the fifth over x squared. X to the fifth is the same as this right here. And x squared is the same as this. If you look at this and ask yourself, what could I cancel here? Well, you could cancel these and these. That would leave you with x times x times x, which is x cubed. How did you get 5 using these numbers? You subtracted 5 minus 2. The last one on this page, the negative exponent one, we'll kind of prove this using an example with the powers of 2, because it's a little bit easier to see that way. So let's say this property right here, let's say we had 2 to the third, 2 to the second, 2 to the first, and then we had 2 to the 0, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, and so on. Well, 2 to the third is 8, 2 to the second is 4, 2 to the first is 2. 2 to the 0, if we follow this pattern, notice that every time you're decreasing this exponent by 1, what's happening to these numbers? And you're taking half of them, and you're dividing by 2. So if we follow that same pattern, we take half of that number, we get 1. And anything at all to the 0 power, any number raised to the 0 power equals 1. Let's follow that same pattern. So if we take half of this number, because we decreased that exponent by 1, if we take half of 1, we get 1 over 2. Or another way of saying that is 1 over 2 to the first. If we take now half of this number, we have 1 over 4, which is the same as 1 over 2 to the second. Half of 1/4 is 1/8, or 1 over 2 to the third. So you might be able to see the pattern. When you're raising something to a negative exponent, that's the same as 1 over 2 to the positive version of that exponent. So the rule for negative exponents is you flip the exponent to the bottom of the fraction, and then you make the exponent positive. Flip it and make it positive is the rule for negative exponents. Okay, these are very similar. So, for example, this problem right here, let's suppose you had x squared y to the fourth and that whole thing to the third. For this, you just take each individual variable and raise it. So x squared cubed would be x to the sixth. Y to the fourth cubed would be y to the 12th. You just treat each one individually. Same thing with these results right here. So for example, if you had x squared over y, that whole thing to the fifth, that would be the same as x to the 10th, because 2 times 5 is 10, and then over y to the fifth, which is there. Okay, slightly different example. Let's suppose you had the same thing, but this time it was x squared over y to the negative fifth. And remember, our negative exponents, we're supposed to flip it and make it positive. So if I flip that thing in parentheses, I have now y over x squared to the positive 5. And now we can apply the same reasoning as before, and we would get this right here. And then we already said that something to the 0 power equals 1. Okay, what does it mean to simplify a polynomial? It means all of these things here. So first of all, no powers of powers. So this right here is not simplified because you have a power to a power. but now it's simplified because I don't have that anymore. Each base appears only once, so this is not simplified because I have the base x appearing twice, but now it's simplified because it's only appearing once. All fractions are in simplest form, so 4 over 8 is not in simplest form, but 1/2 is. And then there are no negative exponents, so x to the negative 3 is not simplified, but now this is simplified, 1 over x to the positive 3. By the way, if you had a fraction where it was something on the bottom that was negative, you would again flip it. If you flip it and it's on the bottom, now it goes to the top and becomes positive. So let's do a couple of these examples. The way that we do these is we take numbers with numbers, so 2 times 3. We take powers of a with powers of a, so a to the negative 2 times a to the negative 3. That's a times right there, by the way. And we take the b's and the c's, but they don't have any terms that go with each other, no like terms, so we're just going to leave those as is. So let's simplify this. 2 times 3, that equals 6. A to the negative 2 times a to the 3, we're supposed to add those exponents together. Negative 2 plus 3 is positive 1. And you don't have to write a to the 1, you can just write a. The b squared stays the same. This is a negative exponent, so it's on the top. We need to flip it to the bottom and make it positive. And that is now simplified. There's no further operations we can do. Alright, this one right here, there's two ways you could do this. Well, we know that dividing exponents means we subtract the top and the bottom. So 4 minus 3 is positive 1. If you look at the numbers here with q, 2 minus 7, that's negative 5. But again, I'm not supposed to have negative exponents, so I'm going to keep the r there, and I would flip the negative 5 to the bottom and make it positive 5. That's one way you could do that. Here's another way you could do it. Let me just make a slightly bigger space here. Here's another way you could do it. If you had the exact same problem, you could say to yourself, well, I have 3 r's right here on the bottom that I can cancel, and I could cancel out 3 of the 4 r's right there. That would leave me with 1. I have 2 q's on the top that I could cancel, and I have 2 out of these 7 here that I could cancel. Notice we have r to the first over q to the fifth, and that's the same thing we got right there. Alright, this last one right here, how should we approach this? We should just take each thing in the parentheses and raise it to the third power. So negative 2 to the third power, a to the fourth to the third power, and b squared to the third power. Negative 2 to the third power, that's the same as negative 2 times negative 2 times negative 2, that's negative 8. A to the fourth to the third power, we should multiply these exponents 4 times 3, we get a to the 12th. And then b squared to the third power, 2 times 3 would be 6. And there's our answer right there. Alright, slightly more complicated ones here. This one here, we're supposed to flip it and make it positive. So if we flip a over 4, we would get 4 over a. And now that's positive. 4 to the third is 64. And a to the third is just a to the third, or a cubed. Number 9 right here is a little bit more complicated, so let's just simplify the tops and the bottoms, kind of each piece at a time. So this one says we take the 5 and we multiply it by these. So we have x to the 2 times 5, which is 10. Y to the negative 4 times 5 is negative 20. On the bottom we can combine x to the negative 1 times x to the 4 by adding those exponents. Negative 1 plus 4 is positive 3. Y to the negative 4 times y to the fourth, we can add negative 4 and 4, and we get 0, but remember, anything to the 0 equals 1, so we don't even really need that there. Now let's simplify this just a little bit further. So we have x to the 10th divided by x to the third. Well, we're supposed to subtract those exponents, so 10 minus 3, that would be x to the 7. Y to the negative 20, we need to flip that to the bottom and make it positive. And then y to the 0 or 1, again, that doesn't need to be there. So our final answer would be x to the 7th over y to the 20th. Okay, these are just some terms that are important to know when you're talking about polynomials. First of all, this definition right here, a monomial, just means a number, for example 6, a variable, for example x, or something that's the product of one or more variables with non-negatives, that means positive, integer exponents. Integer means a whole number like 3 or 4 or 5, and not 3.2 or 3.5 or something like that. So this last one example could be 6, x to the 4th, y to the 6th. That's the product of a number and variables raised to positive integer exponents like 4 and 6. So we'll look at each of these and see if they qualify as polynomials. Letter A does, because all we have are products of variables and numbers. All these exponents are positive numbers and they're all integers. The degree of this one is 5 because that's the largest exponent. The degree of this one is, we're supposed to add those together to get the degree. So we would add the exponents 4 and 3, we would get 7. And you always take the bigger of the two, or the bigger of however many you have. So 7 is bigger than 5, so we would say that this is a polynomial and it has degree 7. Okay, option B is not a polynomial. Here's why. This one right here, we'll talk about this later, but the square root of x, that's the same as raising x to a fraction. It's the same as raising it to the 1/2 power. And if you look at this definition up here, it says that you can only have non-negative integer exponents, and 1/2 is not an integer, it's a fraction. So that does not count as a polynomial. Okay, C, for the same reason, letter C is also not a polynomial because it says non-negative exponents. Those are not non-negative exponents, so that's not a polynomial as well. Okay, simplifying. So we set our goals for this section to talk about the law of exponents, and we just did. And the last three are how to add, subtract, and multiply polynomials. We'll do those things right now. So let's subtract them first. And if you know how to subtract, adding is even easier. Okay, when you have a minus in front of a parentheses, you remove the parentheses and you distribute that minus. So that's what we'll do. That's the first parentheses. Minus the 2x squared is this. Minus the 3x is this. And then this was a -1, but we're minusing a -1, which is the same as +1. Now we can combine the like terms. So 4x squared minus 2x squared is that right there. Then we have, let me just change the color here, we have minus 5x minus 3x, that's minus 8x. And then finally we have plus 6 plus 1, which is plus 7. And that is the simplified answer right there. Okay, that was adding, and well, that was subtracting, but adding is the same. This is now multiplying. There's two types of ways you can multiply. You could start by taking something in front of a parentheses and distributing it. So if you do 3x times 2x squared, 3 times 2 is 6. That's like an x to the first. X to the first times x to the second is x to the third if you add those exponents together like we said before. Then you have 3x times -4x. 3 times -4 is -12. X to the first times, that's another x to the first, would be x to the second. Finally, 3x times positive 6 would be positive 18x or plus 18x. And there is the simplified answer. Last one, it's kind of like the last one, a little bit different though, because you have now two things that you have to distribute. This would be kind of a mess if you had to take both of these and distribute to everything. So the reason it says box right there is what I recommend doing is just making a box, and you can put these three terms right here. You could also put them on the side, it doesn't really matter. And we'll give each of them a column, and then I'm going to take these two terms right here, the n and the positive 2, and give them each their own row. And now we fill in the box by just multiplying these things. So that's an n to the first, that's an n to the first. N to the first times n to the second is n to the third. N to the first times 4n to the first is 4n to the second. And n to the first times -6 is -6n. Same thing on the bottom. 2 times n squared is 2n squared. 2 times 4n is 8n. 2 times -6, -12. What's nice about the box is the like terms usually line up on the diagonal, so those are like terms and so are those. N cubed doesn't have a like term, so it's just n cubed. 4n squared plus 2n squared is 6n squared. 8n minus 6n is plus 2n. And then finally, minus 12 is just minus 12. And that is your simplified answer. So that's 5.1, which is adding, subtracting, multiplying polynomials. In the next video, 5.2, we'll talk about how to divide them.